Welcome to IBCC channel. In this video, we are talking about the link states advertisement of the OSPF. So before we start talking about the link states advertisement, we have to introduce the concept of the router ID. Router ID is a 32-bit unique integers which identify a router in an autonomous system. A router ID must exist before the router runs OSPF. A router ID can be manually configured or automatically obtained. If no router ID has been configured manually, the router automatically obtains the router ID using the following method in the descending order of the priorities. First, the router preferentially selects the largest IP address from his loopback interface as the router ID, regardless whether or not the OSPF is enabled on that interface. If no loopback interface had been configured, router selects the largest IP address from his interface address as the router ID. Also, regardless whether or not OSPF is enabled on those interfaces or not. A router can obtain the router ID again only after the router ID is reconfigured for the router and the OSPF process restart. So this means if you want to change the router ID after the router ID has been selected, you have to reconfigure it and restart the OSPF process. Another thing we need to mention is the router ID must be unique. If two routers have the same router ID in a OSPF domain, then they cannot change routing information to each other. So router ID must be unique. It's important. So now we talk about the link states advertisement. How does the OSPF propagate the link states advertisement between the areas? Before we mentioned, the OSPF is a link states protocol. It has to propagate the link states advertisement to let the other router knows the destination of the network. However, the OSPF area puts a boundary on the link states update. So how does the OSPF propagate the link states advertisement between the areas? The answer is the OSPF designs different types of the link states advertisement based on the character of the link states. The link states advertisement that originated from an inside area router only flood within inside. Sometimes the link states advertisement that originated from ABR. ABR means area boundary router, or ASBR. ASBR here means area autonomous system boundary router can traverse area. So type of the OSPF link states advertisement. OSPF rely on the link states advertisement to communicate the link states information between adjacent neighbor. LSA type is listed below. So OSPF LSA type 1, also named as a router LSA. Type 2, name is network LSA. Type 3, name is summary LSA. Type 4 is ASBR summary LSA. Type 5 is called external LSA. Type 7, name is NSSA, external LSA. NSSA stands for the not so stable area. OSPF LSA type 9, 10, 11 is OSPF link scope opaque LSA, mainly used by the MPLS traffic engineering. OSPF LSA type 6 is OSPF group member LSA. OSPF type 8 is OSPF external attributes LSA. So type 1 to type 5 normally appeared in an OSPF database. is very often used type. This document explains the type 1 to type 5 and also type 7. So we will use this diagram to explain the area types. So we will use this diagram later. First, we introduce type 1 LSA. So type 1 LSA, name is router LSA, also called the router links. The router announces its presence and lists its links to other routers in the same area, together with a matrix to them. Its presence means announce its router ID. The router links are indicators of the OSPF link states of the interface on a router belong to a certain area. Each router will generate a router link for all of his interface belong to a certain area. The type 1 LSA are flood within their own area only. This is the LSA's flood scope. The link state LSA of the type 1 LSA is originating the router ID. So this means the link state ID of the type 1 LSA is originating of the router ID. So below the diagrams illustrate this concept. So basically, type 1 LSA is describing the states and cost of routers links to that area. So let's back to here. You see this diagram. I did some captures. So I capture here. We can see what is a link as it looks like. Let's click that. Open it. Here. Move to here. Okay. So this is the Wireshark grab the packet. So the link RSA is exist in the OSPF or LSA updates. So you take a look at this packet and you can double click. Okay, so you can see the OSPF shortest path first packet here. Click. You see the LSA update packet. Click here. So you see the first one is LSA type 1 router-LSA. So open it. Okay, let's like this. So this is a type 1 LSA. So you can see the first you see some options. Right now we are not talking about options, but you can pay attention to the LSA type. It's called the router-LSA and link state ID. So link state ID is 10.225.25.2. So this is based on this diagram. Basically, router 2 has the loopback interface is 10.255.255.2. So this is router 2 here. Basically, this is a link LSA is generated by the router 2 here. Okay, so also they mentioned advertising router is 10.255.255.2. That means router 2 here. And also they can see the bottom here. You see the link type, the link type transit, There's two link types. There's ID. One is 10.5.0.5. Another link ID is 10.5.0.1. So that the two links is here's two link. On the router 2, links on the interface G0/0 and G0/1. So that since these two interfaces belong to the area 5, so this link update is for the area 5 type 1. When click this, open the link open the link transit, you can see the details, right? So the link ID is 10.5.0.5. Link data is 10.5.0.4. 10.0.5.4 is the interface G0/0. The G0/1's IP address .4 here. Right? You can also see the metric. Metric is 0. Same thing. You can see the another the interface is 10.5.0.1. That's here. That's the interface G0/0. So this is a type 1 LSA regarding this area 5. I think you can see the area from hello here. You can see the area 5 from hello here. Okay, you see this one, area ID here, area ID 5. Area ID 0.0.05 is area 5. So this means, okay, so type 1 is regarding the router's interface which belong to certain area. Type 1 included all the interface belong to certain area on the routers and propagate inside the areas. Okay, I can close this one because I go next. Okay, next is type 2. OSPF LSA type 2. Name is network LSA, also known as network links. Type 2 LSA are generated by the designated router. Designated router acronym is DR. On a multi-access segment to list which routers are joined together by their multi-access segment. DRs will be discussed later. Type 2 LSA are flooded within their own area only. Type 2, this talk about the type 2 flooding scope, same as type 1, own area, within own area only. The link states ID of the type 2 LSA is IP address, is the IP interface address of the DR. So the link space ID is basically the DR's interface ID, which attached to that multi-access segment. Type 2 LSA is an indicator that all routers connect to a particularly multi-access segment, such as the Ethernet. So type 2 LSA originating from a particularly multi-access segment requests at least 2 routers attached to this particularly multi-access segment. So here the diagram illustrates the concept. So the type 2 is only exists for a particularly multi-access segment. Multi-access segment is something like the Ethernet, right? Okay. Type 2 is only be generated by the DR. And what is regarding type 2 is regarding how many what routers connect, how many routers can connect to a particularly multi-access segment, and what is the which routers connect on that. So that is the basic type 2 does, mainly for the for other router to know how to join the network maps. So we can take a look at how do the type 2 LSA looks like. Let's back to this. Let's back to here. So type 2, we can from here we also can see the type 2. We are shock here. Okay, that's the same update. Same update. We can see the same update. We can see the type 2 here. Okay, here is a type 2 here. I close type 2. Okay, type 2 here. This is a LSA type 2 network LSA. Length is a 32-bit. So let's take a look at this one. The link space ID. Link space ID here type 2 is 10.5.0.1. So which one is? Take a look at the pictures. Okay, so link ID 10.5.0.1, 10.5.0.1 is here. It's also the R2, so R2. This means R2. So advertising router is 10.255.255.2. That is R2. So R2's loopback IP address is 10.255.255.2. Okay, so next you can see it just lists the network mask here. So that's the network mask is 2.4 255.255.254. So this network is this network here. So this network is between the R1 between the R2 and the R1. This network is a broadcast network. So they have two routers attached, right? One router is 10.255.255.2. That means R2 attached to this network. Another router is 10.255.255.1. That was R1. That means R1 and R2 both attached to this multi-access network, right? This multi-access network is 10.5.0.0/31. This is the multi-access network here. So pretty much this is what LSA type 2 means. Just told you which routers connect to a particularly multi-access network. Okay, go next. So the type 3 summary router, so type 3 called the summary LSA. So the area border routers take the information it had learned on one of its attached area and summarize it before sending out to another area it is connected to. These summarizations help providing scalabilities by remove the detailed topology information for other areas. Because this routing information is summarized into just the address, prefix, and matrix. The summarization process can also be configured, and that means manually configured, to remove a lot of the details address process and replace them with a single summarized prefix. This helps the scalability. So here's a diagram here, just illustrate the type 3's concept. Type 3 concept basically is say just type basically is type 1 routes hit to the ABR, and ABR took out the details, the topology information of the type 1 routes, and just leave the address, prefix, and the matrix, and change the type to type 3 and send out. So some summarized link are generated by the ABR. This is how the network reachability information is disseminated between the area. Normally, all the information inject into the backbone area first, and in turn, the backbone area will pass it to other area. So this is how the LSA propagate out to the areas. Okay, so back to here. Let's take a look at the package. Okay, here also you can see the package type. Okay, you see here LSA type 3. One the LSA type 3 LSA here. Let's see what it look like, right? So the type 3 options. So we are not talking about options here. We just see what is inside. So type 3 basically information is really simple. So first is a link state ID. Link state ID. Let's see who is this. Back to diagram. Back to diagram here. Link ID is a 10.0.0.0. 10.0.0.0 is R1's interface G0/0 here. So we're summary this links. So basically summaries this links R1's G0/0, right? Advertise the router by the 10.255.255.2. So obviously the 10.255.255.2 is R2. R2 is ABR. So the LSA must be advertised by the ABR. So here is advertised router. So just the list here, just list the network mask here. Network mask here and the metric, right? Mask metrics. Here the link state ID is just the network. Is a network. Is a network. So that's basically this. LS means they receive the type 1 regarding this link, regarding the R1's G0/0, right? Then they strip out the details informations and just leave the mask and just leave the subnet mask, network and the matrix, and change the type to type 3 and send it out by the ABR from the one area. In this case, area 5, go to the area 1. Okay, let's go next. Okay, so type 4. Type 4 name is ASBR summary LSA, and also name is also known as ASBR summary links. Type 4 concept is a little bit weird. Not the people not clear about this. So since type 5, external LSA are flat to all areas with the source as an autonomous system boundary router ID. But the router ID is not advertised between areas since the router ID is a type 1 LSA. Remember, we talked before, type 1 LSA is not advertised, not flood out the areas. So how to solve this problem? This is solved by the area boundary router flood the router ID of the ASBR from where the type 5 is originated. So as long as the ABR flood the total outside what is the router ID of the ASBR is not outside, we'll know how to reach this external routes. That's the whole purpose of the type 4. So the link state ID of the type 4 is the router ID of the described ASBR. Type 4 ASBR summary LSA describes the ASBR's router ID. So this diagram here illustrates this concept. Basically, so the ASBR's router ID as a type 1 LSA propagate to the ABR. ABR is the area boundary router. Area boundary router says, okay, this router is ASBR's, so we have to change it to the type 4 and send a flood out. Yeah, so basically the ABR has a task to propagating the reachability of the ASBR. This is how the router know how to get the external routes in other AS. Okay, take a look at the packet. Okay, to see the type 4 RSA, so I capture the data here. this is the files. So why I capture here, because I want to see how this external routes from here 172.16.51, this external routes from here is propagate into the, or redistribute into the OSPF, then propagate to the area 0. So I will catch that packet. See, here is a packet. Yeah, here is packet here. Okay, this is a type 4. So you see this hello packet is OSPF header is area 0. You see the LSA update packet include the LSA type 4. So from here in type 4, you can clearly see, okay, so either a link state ID is 10.255.25.1. That was router 1. That's perfect, because the router 1, this router 1's the router ID. So that's exactly like the type 4 definition says. So link state ID is the ASBR, in here is R1, the router ID. So and the next advertising router is 10.255.255.2. So this is R2. So that's the ABR. ABR advertising this type 4 only contains one information. Very important is link state ID. So that's how this type 4 works. Okay, let's go next. Okay, let's talk about the type 5 external LSA, also known as external links. Type 5 LSA contains information imported into the OSPF from other routing process. Type 5 LSAs are flooded to all areas unchanged, except the stubborn area and the not so stubborn area. The link state ID of type 4 LSA is the external network's number. So okay, so this diagram just illustrates this concept. This diagram just shows ASBR generated ASBR redistribute the external routes information into the OSPF. And the OSPF generates type 5 LSA for them, then flood this type 5 out. So external links are an indicator of the network outside the AS. Those networks are injected into the OSPF via the redistribution. The ASBR has a task of inject those routers into an autonomous system. Let's take a look at this packet. Let's see, I have here a packet type 5 or not. Maybe we're looking for another packet. Updates. Okay, here I have some packet. Let's see what this packet is. Type 5 advertising router. So okay, see here is the type 5. Type 5. Okay, so area type they call the AS external LSA. Number is 5. ASBR. See here ASBR. So link state ID is 172.16.50.1. Okay, let's take a look. What is this? Back to the diagram. Back to diagram. Okay, so back to the diagram. Okay, so the link state ID 172.16.50.1 is now here in the right hand side. There have the external network 172.16.50.1, right? So this network is redistributed by the R1 into the OSPF. So that's link state ID in this network. So advertising router who advertise this external routes into the OSPF, that's the 10.255.25.1. This is R1. This is correct, right? The R1 is ASPR. He have a duty to redistribute this external routes into OSPF and advertising the related the type 5. So then this is a network mask, and the matrix. That's it. That's for also something called the forwarding address. This forwarding address a little bit complex concept. We will talk about in the coming videos. Okay, let's go next. Last one in this document, type 7 is called the NSSA, external LSA. So routers in a not so stable area do not receive external LSA from area boundary router, but they are allowed to send external route information for redistributions. ASBR in the not so stable area generates type 7 LSA to carry the information about the autonomous system external routes. The type 7 LSA are advertised only within the not so stable area. When the type 7 LSA reach an ABR in the not so stable area, the ABR translates the type 7 LSA into type 5 and flood them into as a normal to the rest of the network. So below the diagram just illustrates this concept. So this area here is a not so stable area. So the not so stable areas not allow type 5 be flooded in. So the ASBR redistributes the external routes into OSPF, and he generates the type 7 LSA and flood this type 7 LSA within this not so stable area. When the LSA reaches to the ABR translates this type 7 LSA to the type 5 as a node. So we can take a look. So we can take a look at this back to the diagram here. Okay, so to capture the type 7, I have to capture from here because this area 7 is not so stable area. So let's double click this, open, and here let's see what 7. I just tap OSPF. Okay, here are some updates. So here is OSPF updates. Over here, see, type 7, yeah, good. Okay, let's see what this type 7 says. So this type 7, you see just the type 7 name here, NSSA, AS external, LSA type 7, link states ID is 10.72.16.71. Okay, so then this network is here in the right hand side. Here have an external network called 172.16.71.0/24. So this external network is redistributed by the R5 into the OSPF. However, this area is not so stable area. They have to change they have to become the type 7. So advertising router is 10.255.25.5. Okay, what is the 255.25? Okay, advertising router is here is R5 10.255.25.5. So that's the ASBR advertising this type 7. So then after I have a network mask, this is /24, right? Okay, so So type 7, only have this information. It's similar with type 5, just a link ID. But here is a forwarding address. Forwarding address is 10.255.25.5. 255.25 is this R5. Forwarding address means is forwarding address. Well, okay, this concept forwarding address is a little bit complex. We can talk about this one in the next coming video. Okay, I think we can end this video for now, or we talk about the type 1 to type 5, and also talk about type 7. So if you like this video, please give the thumb up. Hopefully you enjoyed. Thank you for watching.